and welcome to Space Nexus and the exciting world of astronomy. A team of astronomers has made a groundbreaking discovery of a planet that might be habitable. Yes, you heard it right, habitable. This newly discovered planet, named Proxima-B, is roughly the size of Earth and orbits the nearest neighboring star to our solar system, Proxima Centauri. It's at a distance from its star that allows for mild temperatures that could support liquid water on its surface, a key ingredient for life as we know it. The discovery was made using the European Southern Observatory's 3.6-meter telescope at La Silla, Chile, along with other telescopes worldwide. The scientific team that made the discovery, led by Guillaume and Claude Escude of Queen Mary University of London, will publish its findings on Aug. 25 in Nature. While this discovery has captured the hopes and imagination of the world, there are still many unknowns. Scientists don't yet know if the planet has an atmosphere, which is necessary to protect it from high-energy radiation that could extinguish any potential life. Proxima-B also orbits a red dwarf star, which is far smaller and cooler than our Sun and presents only one face to its star, meaning it doesn't rotate like Earth does. However, despite the unknowns, this discovery has boosted the already existing evidence that such planets are near and possibly sitting close to us. In fact, NASA's Kepler Space Telescope has already revealed a large proportion of minor planets around small stars, and the discovery of Proxima-B within our stellar neighborhood is a significant milestone on the road to finding other possible life-bearing worlds. Upcoming space telescopes, such as the James Webb Space Telescope and NASA's Transiting Exoplanet Survey Satellite, TESS, will be able to follow up on this planet with spectroscopy to determine the contents of its atmosphere. The possibility of more information about Proxima-B could inspire new ideas for interstellar missions and the search for extraterrestrial life.
The universe is one giant box of mystery, and we've been discovering exoplanets all the time since we sent telescopes powerful enough to detect them to space. One of the most intriguing exoplanets is the Proxima, and as such, scientists, including the ones employed by NASA, have spent lots of time studying it. What have they learned about this fascinating planet? Is life present on it? Join us to explore NASA's study of Proxima-B that reveals its secrets. Less than 6 years ago, news broke of the discovery of another planet. Due to its location being outside the solar system, this planet, known as Proxima Centauri b, or simply Proxima-B, is an exoplanet. In the past several years, astronomers have found a large and growing number of Earth-sized exoplanets orbiting distant stars. Some are in the habitable zones of their stars, where temperatures might allow liquid water to exist on their surfaces. However, one reason scientists were very excited by Proxima Centauri b is that the sun it orbits is the closest star to our Sun, only 4.2 light-years away. Proxima-B was detected by Guillaume and Claude Escude and a team of astronomers from the Pale Red Dot campaign. Its existence was further confirmed using the High-Accuracy Radial Velocity Planet Searcher, or HARPS, spectrograph on the ESO 3.6-meter telescope, using a method known as Doppler spectroscopy, or the radial velocity method. This method consists of observing the spectra of stars for signs of a wobble, where the star is moving closer and farther away from Earth. This is caused by the gravitational influence of planets that orbit the star, the extent of which is used to infer the mass of the planets. In the case of Proxima-B, astronomers obtained a minimum mass estimate of 1.24 and a maximum estimate of 2.06 Earth masses. Proxima-B's presence was confirmed again in 2020 using the ESO's Very Large Telescope (VLT) and its shell spectrograph for rocky exoplanet and stable spectroscopic observations (ESPRESSO). Most exoplanets discovered to date were found using the transit method, but for a star like Proxima Centauri, a low-mass and less bright M-type or red dwarf star, that method was not workable. Proxima Centauri b is very similar in size to Earth, with a mass of 1.17 Earth masses. It orbits its star in only 11.2 days, in contrast to our Earth's year-long orbit around our Sun. That means Proxima Centauri b is a lot closer to its star than Earth is to the Sun, but because the star is a red dwarf, which is much smaller and cooler than our Sun, its orbit is indeed within the habitable zone of Proxima Centauri. Interestingly, Proxima Centauri b receives about the same amount of solar energy from its star that Earth does from our Sun. This implies that Proxima Centauri b could have water on its surface. It could be habitable. But, of course, we don't yet know all the details about habitability for exoworlds. But then, many factors affect a planet's habitability, such as temperature, the composition of the planet and atmosphere, water or lack of it, and radiation from its sun. Red dwarfs, like Proxima Centauri, are known to emit flares, and these flares make habitability for red dwarf exoplanets even more complex and interesting, as you shall see in this video. When astronomers confirmed its existence back in 2016, scientists attempted to determine if this exoplanet could harbor life. Sure, it sat in its star's habitable zone, but some studies soon cast the prospect of possible alien life into doubt. As such, the subject of whether life could exist on Proxima-B has always divided the scientific community. However, all of these studies indicate that this question cannot be answered until astronomers characterize Proxima-B's atmosphere, ideally by observing it as it passes in front of or transited its host star. But in a new NASA-supported study, a team led by astrophysicists at the University of Chicago determined that this is an unlikely possibility. The study that describes their findings was led by Emily A. Gilbert, a graduate student with the University of Chicago's Department of Astronomy and Astrophysics. She was joined by researchers from the Alder Planetarium, the Center for Space Science and Technology at the University of Maryland, and the Exoplanets and Stellar Astrophysics Laboratory at the NASA Goddard Space Flight Center. However, even if life exists on Proxima-B, there is something that will make it very difficult. It is known as space weather. As an Earth dweller, when you hear about the weather, you naturally think in terms of the sun, clouds, rain, wind, and so on. If you are familiar with conditions on other planets or moons that have atmospheres, you might think of that kind of weather too. However, space weather isn't related to any of that. It's a sort of weather that originates in stars, including our own sun, and that permeates the space near a star. Space weather consists of ionizing radiation released during flares on the sun or other stars. The radiation can be deadly for any life forms on distant planets. That's especially true, astronomers say, for red dwarf stars, which have more frequent flares than our sun. Red dwarf stars can be very volatile, and Proxima Centauri happens to be a red dwarf star. Astronomers at the University of Sydney in Australia used radio waves to detect and probe the space weather in Proxima's vicinity. This, our Sun's nearest neighbor, is known to have at least two planets orbiting it. One, Proxima Centauri b, which, as we have said, is almost the same mass as Earth, and the other, Proxima Centauri c, is about 7 times more massive. Proxima Centauri b also orbits within its star's habitable zone, where temperatures might allow liquid water to exist on the planet's surface. If you are nodding your head at these as a sign of life, you would be disappointed. The findings of flares on stars like Proxima suggest a grim prospect for life on the planets in this system. Proxima Centauri b is subject to intense outbursts of ionizing radiation from its star because Proxima Centauri b is close to the star Proxima Centauri. It is important to note that an exoplanet existing within the habitable zone does not necessarily mean it can be actually inhabited. This is the case with Proxima-B. Proxima Centauri is a cool, small red dwarf star, meaning the habitable zone is very close to the star, in fact, much closer in than Mercury is to our Sun. Research shows that this makes the planets very vulnerable to dangerous ionizing radiation that could effectively sterilize the planets. Mind you, our Sun regularly emits hot clouds of ionized particles during what is called coronal mass ejections. But given the Sun is much hotter than Proxima Centauri and other red dwarf stars, our habitable zone is far from the Sun's surface, meaning the Earth is a relatively long way from these events, so this radiation doesn't affect us as powerfully. Further, the Earth has a very strong planetary magnetic field that shields us from these intense blasts of solar plasma. With the result of studying the space weather around Proxima Centauri, scientists may assume that all red dwarf stars are not the friendliest places for life. However, there could be other factors at play here for any given planet, such as just how far it is from the star, how strong its magnetic field is if it has one, and so forth. Some red dwarfs are probably also more active than others, relatively speaking, so making a blanket statement regarding situations surrounding red dwarfs is difficult. In further research of the possibility of life on Proxima-B, scientists have also tried to determine what the Earth as a planet would look like if it was orbiting Proxima Centauri. They relied on modeling to work out what the situation would look like. Again, we return to the concept of habitable zones. Just because Proxima-B's orbit is in the habitable zone, which is the distance from its host star where water could pool on a planet's surface, doesn't mean it's livable. It doesn't take into account, for example, whether water actually exists on the planet or whether an atmosphere could survive in that orbit. Atmospheres are also essential for life as we know it because it allows for climate regulation, the maintenance of water-friendly surface pressure, shielding from hazardous space weather, and the housing of life's chemical building blocks. The scientists' computer model used Earth's atmosphere, magnetic field, and gravity as proxies for Proxima-B's. They also calculated how much radiation Proxima Centauri produces on average based on NASA's Chandra X-ray Observatory observations. With these data, their model simulates how the host star's intense radiation and frequent flaring affect the exoplanet's atmosphere. An active red dwarf star like Proxima Centauri strips away the atmosphere when high-energy extreme ultraviolet radiation ionizes atmospheric gases, knocking off electrons and producing a swathe of electrically charged particles. In this process, the newly formed electrons gain enough energy that they can readily escape the planet's gravity and race out of the atmosphere. Opposite charges attract, so as more negatively charged electrons leave the atmosphere, they create a powerful charge separation that pulls positively charged ions along with them out into space. In Proxima Centauri's habitable zone, Proxima-B encounters bouts of extreme ultraviolet radiation hundreds of times greater than Earth does from the Sun. That radiation generates enough energy to strip away not just the lightest molecules, hydrogen, but also, over time, heavier elements such as oxygen and nitrogen. The model shows Proxima Centauri's powerful radiation drains the Earth-like atmosphere as much as 10,000 times faster than what happens at Earth. To understand how the process can vary, the scientists looked at two other factors that exacerbate atmospheric loss. First, they considered the temperature of the neutral atmosphere, called the thermosphere. They found that as the thermosphere heats with more stellar radiation, atmospheric escape increases.
To sum up, the recent discovery of Proxima-B has revolutionized the field of astronomy and presents a significant cause for enthusiasm. It serves as a motivating reminder of the vast expanse of the universe that remains to be explored and the possibility of extraterrestrial life beyond our solar system. We hope this video has provided valuable insights into this groundbreaking discovery. Make sure you like, subscribe, and comment for more content.